Hello, good afternoon all again. We discussed last class about what is that? We discussed about the soft magnetic material. So now we will discuss about the hard magnetic materials. Come to the point. What is this hard magnetic materials? So what is this hard? Actually, what is this hard magnetic materials? Hard magnets are also referred as a permanent magnet or magnetic material that retains their magnetism after being magnetized. Hard magnetic material are used for making a permanent magnet. The properties of a material required for making a permanent magnet are high saturation values, high corrosive force, and high residual magnetism. The hard magnetic material are coming under carbon steel, tungsten steel, cobalt steel, alnico, and hard ferrites. Like that, we have a soft magnetic metals. We have a soft ferrites. We discuss annealing, viscous, magneto-antiquity, grain-oriented steel sheet, iron silicon alloy, pure iron. So like that, we have a hard magnetic materials. So come to the first topic. What is the carbon steel or tungsten steel or cobalt steel? As a soft magnetic material have a narrow hysteresis loss. See, you can see the diagram here. Yeah, you can see the first one is the narrow hysteresis. This is the hysteresis loop, and this is a narrow. But it's a hard magnetic materials. The loop is different, not narrow. It is not narrow. That's why here we can say that. So narrow hysteresis loop. So when carbon is added to a material, its hysteresis area is increased, not narrow. Although it is a cheap magnet are made from carbon steel, lost their magnetic properties very fast under the influence of Knox and vibration. When a material like tungsten, chromium, or cobalt are added to carbon steel, its magnetic properties are improved. That is the point. How the magnetic properties will improve? The magnet, when a material like tungsten, chromium, or cobalt are added to the carbon steel, its magnetic properties are improved. These are the coming under hard magnetic materials. So we know that soft magnetic materials have a narrow hysteresis loop. So when carbon is added to the material, its hysteresis loop area is increased. Although these cheap magnets are made from carbon steel, lost their magnetic properties very fast under the influence of vibration. So when vibration will happen, it lost their magnetic properties very fast in the case of vibrations. So when a material like tungsten, chromium, or cobalt are added to the carbon steel, its magnetic properties are improved. So come to another hard magnetic material, that is called the alnico. Alnico, it is known as the aluminium, nickel, and iron cobalt. Alnico, aluminium, nickel, iron, cobalt. Alnico, it is known as the aluminium, nickel, iron, cobalt. Alnico is commercially that most important of the hard magnetic material. Large magnets are made by a special casting technique, and small one by a powder metallurgy. As cobalt steel is cheaper, so for this reason, the permanent magnet are most commonly made of alnico. This is the important things to all the students, that you have to remember the point that it is known as the alnico. It is aluminium, nickel, and iron, cobalt. Alnico is commercially that the most important hard magnetic materials. Large magnets are made by a special casting technique, and small one by a powder metallurgy, as cobalt steel is cheaper. So for this reason, permanent magnets are most commonly made up of alnico. Remember the point. The permanent magnet is made up of always alnico, aluminium, nickel, iron, cobalt. Alnico. Hard ferrites. What is this hard ferrites? This is you have to remember the chemical formula of hard ferrites. So what is this hard ferrites? Hard magnetic ferrites like BaO, Fe2O3 are used the manufacture of lightweight permanent magnet due to the low specific weight. This is the hard ferrites. Just you have to remember the chemical formula of the hard ferrites. So hard magnetic ferrites like BaOFe2O3 6 are used for the manufacture of lightweight permanent magnet, which is used in our DC generator for permanent magnet, and the permanent magnet is most often made up of alnico due to their low specific weight. So this is the hysteresis like the soft magnetic material, and this is the hard magnetic material we discussed. This is a narrow hysteresis flow, but in case of hard, it is not narrow, it is a wide, it is something extra, something we add. It is a hard magnetic materials. So it is a its hysteresis loop is different. So what is the basic difference of hard and soft magnetic material? What is the basic difference? So I have a large hysteresis loop. First of all point, the hard magnetic materials is a large hysteresis loop we discussed. That is, you can see this is a large hysteresis loop. But soft magnetic materials, low hysteresis loop. You can see here, there is a low hysteresis loop. Domain wall movement is different. Domain wall movement is different. Its movement is difficult. Domain wall movement is relatively easier. You can say that it is easier, and it is a domain. It's correctly. You can say it is easier. Cannot be easily magnetized and demagnetized. Can be easily magnetized and demagnetized. It is a difference between the hard magnetic materials and the soft magnetic materials. So magnetostatic energy is large. Magnetostatic energy is small here. Have a small value of permeability and susceptibility, and it have a large value of susceptibility and permeability. Used to make a permanent magnet. We discussed already that hard magnetic materials are generally used as a hard permanent magnet in DC generator motors. So it is basically used in a permanent magnet. We use in a DC generator and motors. That is a permanent magnet, and it is made up of alnico material. Okay, and it is used for electromagnet. Soft magnet is used for an electromagnet. So this is the structure. This is the structure of soft and hard magnetic materials. And last point, not but the last point. So this is the you can say it is the soft magnetic materials and this is the hard magnetic materials. So you can say that now iron, nickel, aluminum. Last point was iron, nickel, aluminum alloy, copper, nickel, iron, copper, nickel, cobalt alloy. But soft magnetic materials are iron, alloy, ferrous, nickel alloy, ferrites, granites. These are the soft magnetic materials. These are the examples of different. What is the difference? What is the basic difference between the hard magnetic materials and soft magnetic? You get 5 marks. Maybe you get in your semester 5 marks question that what is the difference? What is the basic difference between the hard magnetic materials and what is the basic difference between the soft? What is the basic difference hard magnetic materials and soft magnetic materials? So we will explain in this way. So here the correctivity and relativity is the large. Here correctivity is small and can be easily magnetized and demagnetized. Can be easily magnetized and demagnetized. It cannot, but hard magnet cannot be easily magnetized and demagnetized. Can be easily magnetized and demagnetized. And here one thing is important is that point here have a small value of permeability and susceptibility, but here have a large value of susceptibility and permeability. Used to make a permanent magnet is important. It is used to make an electromagnet. It's the common point. It have a large hysteresis loop, but it have a low hysteresis loop. You come to the figure. This is the soft magnet. Is a large hysteresis loop in case of hard magnetic materials, but in case of narrow hysteresis loop in case of soft magnetic material. You can see. So we discussed about the soft magnetic material, hard magnetic materials, and these are the corrosive here. You can see the diagram here. Soft ferromagnetic materials. Here small corrosive force is there inside the loop, but here large corrosive force is present inside the loop. You can be defined in this way also the diagram. And any questions regarding this we will discuss. This is a very interesting chapter, magnetic material. This is soft magnetic material and hard magnetic material. Corrosive force is very large in case of hard ferromagnetic material. but corrosive force is small in case of soft magnetic material.